Okay, so we're practicing solving problems that involve quadratic equations. This one maybe doesn't look like it's going to involve a quadratic equation yet, but you'll see that it does here shortly. Okay. So when you get one of these things, if you're a genius level person and you love doing this stuff, you probably can see what the equation is, but most people can't. Okay, so what I encourage people to do is say, look, just draw a picture of what's happening and say, here goes Smith, and he's going at, 4 miles an hour. Okay. Here goes Jones. He's going at 5 miles per hour, but this is 2 hours later. Okay. And if you can see the equation that says, oh, hey, I know, I'll just figure out how many hours it takes till they're 40 miles apart, then that's great. Most of us can't do that, so what I tell people to do is just take a guess. Okay? So we're going to guess first 6 hours. Okay? And then think it through here. If Smith's going 4 miles an hour for 6 hours, he's going to go on 24 miles. Okay? Jones, you might say he's gone 30 miles, but don't forget he left 2 hours later, so he's only been traveling for 4 hours. Okay? It's been 6 hours, but he's only gone for 4 hours, so he's gone 20 miles. Okay? Well, now, here's the question. If Smith goes 24, Jones goes 20, will they be 40 miles apart? Well, you might recognize a right triangle in here, so we'll use what we know from right triangles, that the two short sides squared should equal, two short sides squared and added together should equal the long side squared. So calculate that up and you'll find out it's not true. This didn't actually work. Okay, so we'll try a different number. How about let's try, instead of 6 hours, let's try 7 hours. Okay, and we'll redo this. At 4 miles an hour for 7 hours, he's going to have gone 28 miles. You might be tempted to say, well, 5 miles an hour for 7 hours, that's 35, but don't forget, he's been only going for 5 hours, so 5 miles an hour for 5 hours, that's 25 miles, and you'll redo this. You'll say, well, is 28 squared plus 25 squared equal to 40 squared? And you'll calculate away and find out, nope, that didn't work either, so try again. It seems like cheating, but remember, if you get the problem right and you're able to answer it, then it's not cheating. It just takes longer to do guess and check, but it always works. So if we're going to try, let's say, 8 hours, then at 4 miles an hour, Smith will have gone 32 miles. Jones, remember, he hasn't been going 8 hours. He's only been going for 6 hours. So 6 hours at 5 miles an hour, that's 30 miles, and you can check that and see if that's correct. Is that equal to 40 squared? And you'll calculate it and find out, nope, that's not true either. So eventually you're going to narrow it down, or you're going to say, look, I can save time eventually by saying, I'll just use this same pattern. Instead of guessing another number, we'll just guess h for hours. Okay? And then you can ask yourself, well, how did I calculate each of these numbers? Well, I multiplied 4 times the number of hours I had. So 4 times h. Okay? And then over here, how did I calculate this number? Well, I took the number of hours I've been going, subtracted 2, and then multiplied that by 5. So here's the number of hours we've been going. Not x, it's h, sorry. H hours. Subtract 2 from that, and then multiply that by 5. Okay? So here's how far Jones has gone. I'm sorry, Smith has gone. Here's how far Jones has gone. Now, if you don't mind, I'm going to write that as 5h minus 10 using the distributive property. Okay? And then what did we do to check and see if we were right? Well, each time up here, we took Smith's distance squared plus Jones's distance squared, and hopefully had it equal to 40 squared. So what we're going to do is write that same thing here. Here's Smith's distance squared. Here's Jones's distance squared. And we're trying to have that be equal to 40 squared. So this doesn't look like a quadratic equation yet, but it will soon. I'm going to copy that over here to the next page. So here's Smith's distance squared. Here's Jones's distance squared. And it's supposed to be equal to 40 squared. So let's take on some stuff and make this happen. Now, first, I'm going to write this as 5h minus 10 squared. I'm going to write it this way. So I've got the same thing here. I just wrote that down as squared. And the reason I did that is because now I'm going to FOIL this this business right here. I'm going to write that as 25h squared. That's the first pair. Outside pair is 5 times negative 10, so that's negative 50. But then here's another negative 15 here. So I've actually got negative 100h plus the last pair is 100. Okay, I'll bring down everything else for the right, but I'm going to write this as 16h squared. So I squared the 4 and I squared the h. It's supposed to be equal to 1600. That's 40 squared. And so now we're starting to look more like a traditional quadratic equation. Let's combine these into one thing. That's going to be 41h squared. Here I've got a negative 10 or negative 100h, and then I've got 100 here and 1600 here, but I want 0 right here. So I'll subtract 1600 from each side and get negative 1500 equals 0. And now you can use the quadratic formula and find out what h is. Okay? Good luck on that stuff.